So today what we're going to do is we are going to be creating a book of parent functions. So we are going to learn about the functions that we are going to be doing transformations to. And this is going to become more clear what this is throughout this week. So we have this book here that shows all the different parent functions. So what we're going to do is we're going to be using our graphing calculator in order to graph each of these functions. And then later on in the week, we'll talk about how we can do different mathematical operations to these in order to transform these functions to maybe look a little bit different. So first here we have Blank's book of parent functions. So I want you to write your name there because it's your book of parent functions. So here I'm going to write Miss Carrigan's book of parent functions. So the first function that we're going to look at is a linear function. And remember, we see that word line in linear telling us it's going to be a straight line. So we're going to turn the calculator on, go to y equals, clear whatever's in y equals, and we're going to type in f of x, or in other words, y equals x. Then we're going to go to our table, and we're going to copy down the table that's given to us there. So negative 2, negative 2, negative 1, negative 1. And then we're going to graph these points. Before we graph this function, you'll notice your axes aren't very bold. So what I'm going to do is I'm going to just bold over them with my pen to make sure that I am graphing each of them correctly. Then we're going to graph our points that we got from our table. And we can use our calculator to check that our graph is done correctly. And we have our straight line here. So we're just going to take our ruler, draw our line, make sure we have our arrows at the end, and we are labeling it. So the next parent function we have is absolute value. We're going to go under y equals again, clear out anything that we previously had. Now, if you remember how to find absolute value in the calculator, what we're going to do is click the math button. Then we're going to go over 1 to num. And then number 1, ABS, is where we click enter. That gives us our absolute value of, and then we want to put in x. We're going to go over, and then we're going to go to the table. And we're going to draw in our table that we have here onto our paper. And then what we're going to do is we are going to graph this, and we can click graph to see what that graph would look like. So if we notice, this graph is similar to a parabola because it is a symmetrical graph. So it's the same on one side as it is on the other. But what's different about this, instead of coming to that U-shaped curve here, it comes to a point, so it's more like a V. So we're going to graph that, and instead of that U shape, remember it is a straight line connecting, so it makes that V shape for us. And this would be our absolute value function. So next we have our quadratic, which is what we're very used to seeing from this unit. So under y equals, I'm going to type in x squared, and we're going to go to the table. And then we're going to draw our table and graph our points. And when we graph this, remember, it's going to have that parabola or that U-shaped curve. So we want to make sure that we have that U shape, because if not, it'll look like that absolute value graph. Okay, then we have a cubic function. So a cubic function, we're going to type into the calculator x, and then it's to the third power. So we're going to put it to the third power and go to our table. So then we're going to graph it. If we look at the graph, it's this weird squiggly curve, so something different than we're used to seeing. So even though our graph doesn't go to 8, I kind of estimated where the negative 8 would be. Just to help our picture look like that. So it's that squiggly shaped curve there. And we're going to label it. So next we have the square root function. So we are going to put that into our calculator. Remember, to get that square root button in the calculator, we need to hit second, and then x squared will give us the square root of x. And then we're going to go to the table. Now, something to notice in the table. If you look here, -1, it says error. -2, it says error. If you keep going, any of the negatives say error. Why do you think that this is happening? Well, if you think we're taking the square root of something, can you take the square root of a negative number? No, you can't. So that's why it becomes an error. So whenever we're doing square root functions, we're not going to have any negatives as our parent function. So the square root of x will not be going into the negatives. So we're only going to worry about those positive values. So we're going to write our table in there. And notice it's only giving you perfect squares to take the square root of when we're looking at our table to make it nice and easy to graph. So remember, we only want to graph those nice and easy numbers. And then let's look at what the graph looks like. And it kind of looks like just a little curve slowly going up. So we start at 0, 0, then we go to 1, 1, 4, 2, and 9, 3, and we can't fit 16, 4, and we're going to draw it like that, and it continues going up. Now notice when I do this, there's arrow at this end, but there's no arrow going the other way because you cannot go into the negatives here. And then we always want to label. And then lastly, we have an exponential graph. So we're going to put this into our calculator. So we have 2, and then we want to raise it to a power, so to the, and it's to the x power. So we'll go to our table there. So we got to scroll back in our table. So here we have -2 is 0.25, -1 is 0.5, 0, 1, 1, 2, and 2, 4. So now if I keep going down to my negatives, the numbers keep getting smaller and smaller and smaller and smaller. But one thing that we know is that it's never going to hit 0. As small as we go, it will never actually hit 0. So when we graph this here, I'm sorry, those are wrong. So it's -2, 0.25, -1, 0.5, 0, 1, 1, 2, and 2, 4. So notice it keeps getting closer and closer, but never actually hits that point of 0. So what we call that there is an asymptote. So that is an asymptote. It gets closer and closer and closer to something, but it never actually hits that value. So it gets closer and closer and closer to x, but it never actually hits that value of x. So that's an exponential function. So to create your book of parent functions, so to make this into more of a book, what I want you to do is cut a slit from here to there with a scissor. Then after you do that, I want you to fold all in half. And then I want you to fold along each of the lines. Okay, so then you're going to fold it in half and tilt it. And what you'll do is you'll create a diamond-like shape, like this. And you'll be able to fold your book so that you have a book of parent functions. So each of the functions make up a book. Now, if you cannot fold it properly the way that I did, that's okay. You can just fold it to make whatever type of a book that works for you. All right, so I hope you enjoyed your book of parent functions. Keep this handy. We'll be using this throughout the week. And once again, if you have any questions, please comment them on the video below.